Happy Tuesday afternoon. So, as we begin our final unit of study here, this is chapter 9 of your textbook. I'll try to send pictures along too, and I have a homework sheet. But it's actually a fun chapter. It's finishing off trigonometry for the course. We're going to be focusing on non-right triangles, so I'll try to review some geometry here for you as well. But a couple things, notation. IB notates angles in a slightly different way. Sometimes they put, instead of the angle notation that we see that resembles the less than sign, they put, it looks like a rotated angle on top of the vertex. So like if we're talking about angle ABC, the IB also notates this as angle ABC, and they put the angle notation on the vertex of the angle B. The other thing too, we're more accustomed to degrees, right? But if the angle's in radians, they might put a C in the exponent spot. So watch out for that. Rounding, once again, pay attention. If they don't tell you anything about rounding, 3 sig figs. Otherwise, use your best judgment, of course, read the directions. And the mode of your calculator ideally should be in degrees, once again. So what you'll notice for today, we're going to study the area of a triangle. In order for us to find the area of a triangle, you should have 2 sides and the included angle measurement. So you might remember from Common Core geometry when you did triangle proofs, side, 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 angle, angle, side, angle, and HL. Well, today we're going to focus on side, angle, side. Doesn't matter which 2 sides and the included angle they give to you, but if you have that piece of information, you can find the area of the triangle. And the area form of the triangle is given on your trig formula sheets. Area equals 1/2 AB sine C. Now, in case you're rusty with geometry, if you remember, the lowercase letters are reserved for the sides of the sides of your triangle, and the capital cases, remember, are reserved for the angles. So let's suppose this is side A and this is side B. That makes this angle C. So if that's side A, you got it. This would imply angle A. And if this side B, this would imply angle B. And if this angle C, this will be side C. So don't forget all that geometry. Comes in handy as you prepare for SATs and ACTs. Don't know where that is right now either. So in order to find the area of this triangle, we write down the formula. Area equals 1/2 AB, the sine of angle C. So the area of this triangle is 1/2 the 2 sides, 1/2 times 9 times 10, and it's always the sine, not cosine, not tangent. It's always the sine, S-I-N, of the angle 40 degrees. So after the calculator, I'll go. Double check the mode of my calculator. I have been resetting this for my IB Math 2 lessons. So my calculator is in radians. Let's change over to degrees. So now, again, it's up to you. I know the equivalence for 1/2 is 0.5, so I just go right to it. 0.5 times 9 times 10 times the sine of 40 degrees, and close your parentheses. Especially in this chapter, it's going to be very important for you to get into good habits of closing your parentheses. They didn't tell me what to round, so 3 sig figs will be, you got it, 28.9. And that is your answer for example number 1. Here's another example number 2. Oh, look at that. Miss Dewar gave you a radian measurement. Not a problem. I can find the area of this triangle. It'll be 1/2 times 8 times 12 times the sine of 1.3. It's in radians. Not a problem. I'm just going to go back to my handy-dandy calculator, and I'm going to change it back into radians. And once again, 0.5 times 8 times 12, close your parentheses, just getting a good habit, oops, and I just did not, times 12, and close your parentheses, times the sine of 1.3 radians. Just type in 1.3, practice parentheses, 46.3. So you'll see some practice of that here. So that's finding the area of these non-right triangles. You must have 2 sides and the included angle. Now what if you're working backwards? Like example number 3, a triangle has, area is 55 meters squared. The triangle has two sides of length 10 and 12. So you could draw a picture if you want, if it helps. Two sides, 10 and 12. Find all possible values for the included angle. So I'll label the included angle, angle C. So area equals 1/2 AB sine angle C. Fill in what you know. 55 equals 1/2 times 10 times 12 times the sine of angle C. So we're trying to find the angle whose sine will be equal to what we end up getting here on the left. This should resemble something you saw last chapter, trig equations, right? So 55 here is equal. What is 1/2 times 10 times 12? 60 sine of angle C. Divide both sides by 60, so we are in the hunt. 55/60ths, that decimal gives us the sine of angle C. Now bear in mind, sine is positive in quadrant 1 and quadrant 2, and if you remember from our last unit, the calculator is only programmed to give you quadrant 1 answer. You got it. So off to the calculator I go. Again, double check the mode of your calculator, so now we're in degrees. So second sine inverse, type in the fraction 55/60ths, and it didn't tell me what around nearest degree, so 3 sig figs would be 66. Okay, wonderful. So one possible answer for angle C is 66.4 degrees. That takes care of my quadrant 1, as expected. But sine's also positive in quadrant 2, so to find the quadrant 2 angle, if you recall, we draw and label the reference angle 66.4 and do some arithmetic. 180 degrees minus 66.4, 113.6, but 3 sig figs would have been 114 degrees is fine. So you're going to see some practice of that from our last chapter. So if you enjoy doing trig equations, that's pretty much the basics that you will see. Now the next example is similar, but I want to give you an example. It's not 100% the case you'll have two answers. So number 4, the triangle has an area of 10 this time, meter squared. The triangle has two sides of length 4 and 5. So if I use the area formula, 10 equals 1/2 4 times 5 times the sine of angle C, there's only going to be one possible answer. It's kind of rare, I know, but can happen. 1/2 of 4 is 2 times 5. You're going to get here 10 equals 10 sine of C. And if you divide both sides by 10, you're looking for an angle whose sine is 1. There's only one answer to that. And if you've forgotten, sine inverse 1. No, oh my goodness. So this is an example where angle C is a right angle. It's kind of rare, but I just want to show you an example. It can happen. I don't want you thinking it's always going to be like number 3. That's probably 98% of the time. If you have any questions, maybe now's a good time to stop and pause as we finish up the lesson. Some old SOHCAHTOA review stuff. So I call it oldie, but still is a goodie. Number 5. In the following diagram, O is the center of the circle, and AT is the tangent. Now, quick reminder from Common Core geometry. When you draw the tangent, angle T right here is very, very special. Do you remember what kind of angle you're going to have? You got it. It's a right angle. This is a tangent and this is a secant. Okay, keep that in mind. If O to A, this secant O to A is 12, and the circle has a radius of 6, take a look at those numbers. 6 is exactly half of 12. Find the area of the shaded region. Now here, I do tell you to round your answers to 3 sig figs. But this, if this is a right angle, this is a hypotenuse, which is exactly double that. What kind of angle is angle A? Yep, that's a 30-degree angle. That makes us 60 degrees. And I want to find the area of the shaded. Now, which is larger? This triangle or the shaded? The triangle, of course. So find the area of the triangle first, which will be 1/2 of 60. Oops, I don't want to do that yet. 1/2 of 6 times 12 times the sine of 60 degrees. So the area of the triangle is going to be 1/2 of 6 at 36, and the sine is 60. You might remember radical 3 over 2. Now, it did give me permission to round, and 36 square roots of 3 over 2 is exactly 18 square roots of 3. So I'll hold on to that because I know that that triangle is larger, but I'm going to have to subtract the area of this sector. Oh, we did that back in March, right? The area of the sector, if you recall, is 1/2 the radius square theta. However, do we use 60 degrees? And the answer to that is no. We need to convert 60 degrees into radians. So 60 degrees times pi over, oh yeah, that's right, pi over 3. So the area of my sector will equal 1/2 6 squared pi over 3. 6 squared is 36, but half of 36 is 18. So we're going to get here 18 pi over 3. So if I type this in the calculator, get the decimal, I'm going to take 18 square roots of 3 minus 6 pi. And I would wait to the very, very end to try to round this problem. My fear is if I round it here and then there, I'm going to be rounding all the time, I'm going to get the wrong answer. So off to the calculator I go again. 18 square roots of 3, arrow out, minus 6 pi. And the answer I get here, 3 sig figs is about 12.3. 12.3. Now I tell boys and girls, what if you get a negative answer? Check. Maybe you had this switch. Maybe you thought the sector, this little piece of the circle, was larger than the shaded region or the whole triangle. So again, if it helps, do a highlighter and try to trace I wish I had my smartboard because it's so much easier on the smartboard. But if you trace the sector and the triangle, you'll see that the whole triangle was larger. So that happens. Sometimes it's a mode issue. You put the calculator in the wrong mode. So double check that. But as you can see here, for my problem, did it make a difference? No. Now this is an oldie problem. I could have given this to you back when we were doing the angle, the sector, area of the sector question, which I think I did. I think it might be an old problem from the book. How does it apply here? Well, what if I don't give you a nice right triangle? So like number 6, find 3 sig figs the area of the shaded region. Now, this angle here is not a special angle from the 30-60-90 triangle. I mean, I do know that the radii of a circle are the same, so I can find the area of this triangle. But which one is bigger, the triangle or the sector? The sector. So I'm going to find the area of the sector and subtract out the area of the triangle. Now the area of the triangle is actually easy to solve. 1/2 12 times 12, and the sine of, I forgot, was it 1.8? Yeah, 1.8. Now it's in radians, so I'm going to put the C there. So this now tells me, my mode. My calculator should be in radians, okay? Now I got to find the area of the sector. Well, luckily for me, that is already in radians, so the area of the sector will be 1/2 12 squared, and just the angle, which is 1.8. Thank goodness, already in radians. But to find this answer, off to the calculator go, my mode needs to be in radians. And you can very carefully type it all in. So 1/2 0.5 times 12 squared times 1.8 minus, now I got to enter the area of the triangle, which I might put parentheses around here, 0.5 times 12 times the sine of the angle 1.8. And close the parentheses, and voila. There's my answer, 59.5, rounded to 3 sig figs. So this is an oldie. We've done this problem. Like I said, I think that's an old homework problem. The difference here is, what if we step away from a non-right triangle, a traditional triangle? No 30, 60, 90 is in store for us. We do have to use our formulas. And again, once you write down the angles, pay super duper close to the mode of your calculator. Will it match? Will it be in radians? And as long as your calculator's in radian mode, you're good to go. I'll go ahead and I'll post a picture of the exit ticket for you on Remind, so I'll give you a chance to try that and take a look at the homework. Let me know if you have any questions. Have a great day. Thanks.